So these are the notes for Module 15.3. Again, we're still talking a lot about triangles. And in this case, our central question up here at the top, how can you use triangle inequalities to describe the relationships among side lengths and angle measures in a triangle? So we're really talking about side lengths and angles and how those relate to each other in within those triangles. So the first theorem we have something called the triangle inequality theorem. The sum of any two side lengths of a triangle is greater than the third side. So if I can prove these three inequalities, saying that AB plus BC has to be bigger than AC, and then we could say BC and AC, so BC and AC would have to be bigger than this third side, AB. And then similarly, our last inequality there, we have AC and AB has to be bigger than BC. So to be able to form a triangle, all three inequalities must be true. Okay, so each side, the sum of those two sides has to be greater than the third side, and those all have to be true. So to prove that they can't form a triangle, you only need to show that one of them is false. So that's the nice thing with these types of problems, is if you can show that one of them is false, that one of them doesn't work, then you can stop. Like if your first one is false, boom, you're already done, because you know that all three of them aren't going to work because you know one of them is false. So example 1, determine whether a triangle can be made with the given side lengths. So we're going to have three inequalities here for example A. The first one I have to check is 4 plus 8 greater than 10. And so 4 plus 8 is 12. And is 12 greater than 10? Yes, it is. That one checks out. So the next one we have to check is 8 and 10. Is 8 and 10 greater than 4? Well, again, 8 plus 10 is 18. And is 18 bigger than 4? You bet. And then the last one we have to try is 10 and 4, and does that have to be, is that bigger than 8? So 10 plus 4 is 14, and is 14 bigger than 8? Yes, it is. So can we make a triangle? Yes. A triangle can be made. And we put a happy face, because we're happy that we can make a triangle. So example B, okay, again doing that same thing, checking all of our inequalities here. 7 plus 9 has to be bigger than 18. 7 plus 9 is 16, and is 16 bigger than 18? Hopefully you said no, that does not work. And so since I've proved that that one is false, right, false, we're done, right? It doesn't matter if I check the other two, because that one's already false. And so it's all three of them aren't going to work because I have one that doesn't. So we can say no, a triangle can't be made. And we put a sad face because we're sad. Now, you may have noticed while doing the first problem, example A, that there's kind of a shortcut because you really only need to check one of them. And the only one you need to check is if the sum of the two smaller numbers is greater than the biggest number. And so, for example, in example 1, letter A, right? We already know that 8 and 10, that that 8 and 10 are bigger than 4, just on their own. So since we have 8 and 10 is bigger than 4, we already know it's going to be bigger. And 10 is already bigger than 8, so it doesn't matter what I add to it, that's still going to work. Here, this first one is the only one that we're not sure of, right? This number and this number are both smaller than 10, and so I have to make sure that when I add them up, it is actually bigger, which in this case it was. So this situation where I take my smallest number, my smaller number, plus my other small number, has to be bigger than the biggest number, okay? So, that being said, letter C. Okay, first of all, what you want to do is establish what are your smallest numbers. And if you want, right, you can even label them small, medium, and large. So we have 12, 4, and 17. 4 is going to be my small, 12 is going to be the medium, and 17 is going to be my large. So if we take small plus medium, it has to be greater than my large side. We do 4 plus 12 has to be greater than 17, and 4 plus 12 is 16, and that is not bigger than 17. So can we make a triangle? No. A triangle can't be made. So go ahead and pause for just a second and try letter D and see what you come up with. So for letter D, again, if you want to label your 3, we have small, medium, and large. So small plus medium has to be bigger than my large. And so we have 8 plus 24 has to be bigger than 30. 8 plus 24 is 32. And is 32 bigger than 30? Yes, it is. So yes, a triangle can be made. I'm going to put a happy face, and I forgot on the first problem to put a sad face, so I'll go back and do that. Okay, but that is using your triangle inequality theorem. Okay, again, the sum of the two smaller sides, right, your small and your medium side, have to be greater than your third side, your biggest side. So now on the next page, okay, finding possible side lengths. So for any two given side lengths, there's an infinite number of third sides, right? There could be infinitely many. I can't tell you an exact amount. You could put in infinitely many. However, that triangle inequality theorem that we learned on the previous page does restrict that to a range of values. And so I can't say that it's any number ever, but it does say that there is a limit to what I can do. So to find that, okay, you'll notice that we have two sides in example 2, letter A. Right, here's 12 and 10, and then I have this third side, x. And so I don't know which one's my smallest, which one's my medium, which one's my biggest. And so we don't know. And so to find our range of values, again, we use our triangle inequality theorem. And so we know that 10 plus x has to be greater than 12. So x has to be greater than, if we subtract 10 from both sides, greater than 2. I know that, let's see here, split that up. We know that 12 plus x has to be greater than 10. So if I subtract 12, x has to be greater than -2. And now my question is, can we have a side that's -2? Not particularly, right? So that one may not help us very much. And so let's try the third one. So we've got 10 and x, 12 and x. Now we need 10 and 12. So 10 plus 12 has to be greater than x. And so if we just combine the left side here, that would give us 22 has to be greater than x. Or we could rewrite this as x has to be less than 22. I'm just flipping around my entire expression there, my inequality. And so again, right in this middle, x is greater than -2. Wouldn't make any sense to have a negative side value. I can't say it's -1 centimeter long. So that's one we're not going to worry about because we can't really use it. It doesn't really make sense. But we have these two on the sides, x is greater than 2 and x is less than 22, that we can use. So if x has to be greater than 2, so x has to be greater than 2, but x also has to be less than 22, we can actually combine these into one inequality. And how we would do that is this. We would say, here's x in the middle. It has to be less than 22, but it has to be greater than 2. And so the tricky part here is this sign right here, right? If I just focused on this, this would read 2 is less than x. And so this part right here is a little tricky because we just wrote it on this side as x is greater than 2. But again, the same thing, 2 is less than x going the other direction. And so we can combine that into one inequality, and that just makes our lives a little easier. And so that would end up being our final answer. X has to be between 2 and 22. Any number in between those, you can use decimals, you can use fractions, any number that falls in between those two numbers, we can use. Now what you'll notice is, can it equal 2 and 22? And in this case, you should think no, right? Our inequality said it had to be greater than. It had to be specifically larger than. So we cannot include the equal sign there. It's just simply greater than. Okay. Now, there is a little bit of a shortcut to this, if you didn't realize it already. And that is this, right? Ultimately, which ones did we end up using? Well, I used the ones where I did 12 minus 10, and the one where I did 12 plus 10. So we can make our range, our final answer here, out of those two expressions. We take the two sides that we do know, and our lower bound is going to be the subtraction, and the upper bound is going to be the addition, right? We subtracted to get the lower bound 2, and we added them together to get 22. Okay, so the range of our missing third side is going to be the difference between the two sides, which again is our subtraction. And the right side, right, then we have, again, the same thing right here in the middle, right? This doesn't change. We have a less than sign, and then an x, and then a less than sign. And then on the right, we're going to have the sum of the two sides, which is our addition, right? We're going to add. So to show you an example of this, write letter B. So we have x, 15, and 15. And so, again, by that triangle inequality theorem, right, we have the difference is less than x, which is less than the sum. And so 15 minus 15, and we have 15 plus 15. On the left side, the difference, 15 minus 15, is 0. On the right side, 15 plus 15 is 30, less than x less than, and there we have it. That would be your final answer. Okay, it's that simple. So go ahead and pause the video here and go ahead and try C and D and see if you can come up with the correct answer. So letter C, again using our triangle inequality, the difference has to be less than x, has to be less than our sum. So 21 minus 14, 21 plus 14. So on the left, 21 minus 14 is 7. 21 plus 14 is 35, less than x and a less than. And there's our answer. 7 is less than x, which is less than 35. So again, what this means is our x has to be in between those two numbers, 7 and 35. So it could be 8, it could be 9, it could be 20, it could be 27, it could be 15.3792. I don't know, I just know it has to be somewhere in between those two values. And so then letter D, again, our difference is less than x, which is less than our sum. And so we have 18 minus 9 and 18 plus 9. 18 minus 9 is 9. 18 plus 9 is 27, less than x less than. And ta-da, we are done. Okay. So again, that is if we have two of the sides and we're trying to find that missing third side. Okay, if we don't know what that third side is, I can't say exactly what it's going to be, but we can say that it's going to be in between these two values. It's somewhere in this range of numbers. Now, the last section here, okay, ordering a triangle's angle measures and side lengths. So now we're kind of showing that relationship between the angles and the sides. So the largest angle, naturally, is going to be across from the largest side. So, in this case, we have a triangle. And what I would do first is I would go through and I would label which one is your largest side, your medium side, and your smallest side. So if we look at our triangle, our largest side is going to be 7.2. Our medium side is 6.5. And our smallest side is 4.3. Okay, so hopefully you agree with that. And so I'm going to go ahead and we're going to label those. So the largest side was side what? It's this one right here. And so that's going to be side BC or CB, however you would like to write it. Does not matter. So side BC. Our medium side was this one here, and that would be side AC. And then our smallest side is that last one, side AB. Now, again, the largest angle is across from the largest side. So if we look at our triangle here, here's our largest side, right here, 7.2. And so what angle would be across from this side? So if here's my side, what angle would be across from it? All right, if I go across my triangle, a better arrow there, that would be angle A. So angle A. My medium angle would be across from my medium side. So again, if we look at the blue line, we're going to go across from that. That's going to be angle B. And then again, my last one, I'm kind of down to 1 at this point, but across from my smallest side is angle C. And one thing I want you to notice is for my largest side, right, we had BC. And so of my triangle, right, we had triangle ABC. What letter is missing there? Well, it's letter A, right? That's the one across from it. And for my medium side, AC, what letter is missing? Letter B. That's my angle that's across from it. And again, small side is AB, and across from it is angle C. Okay, so if you can use even that to kind of help you out, right, the relationship between those letters there, that's another way you could also think of it, right? Which letter is missing? That's the one that's I'm not using already. That's got to be the angle that's across. Okay, so that's finding the largest angle using my sides. And if you go ahead and flip to the next page, we can also say that the largest side is therefore across from the largest angle. So again, I would go through and kind of label here. We've got our large angle, we have our medium angle, and we have a small angle. And so the large angle is going to be angle P. The medium angle is angle R. And the small angle was angle Q. And so again, across from our largest angle, I go straight across, is that side right there, which is the side RQ. Our medium side is across from our medium angle, so if we go straight across, that's going to be that side, which is PQ. And my smallest side is across from my smallest angle, which is the side PR. And again, if you notice that relationship with your letters, right? We started with the largest angle and said, okay, what two letters are missing from P, Q, and R? Well, it's R and Q. Which one's missing from angle R? Well, that's P and Q. And from angle Q is P and R. Okay, so again, if you can even recognize that within your triangle, right? What two letters or what letter am I missing, depending on which direction you're going, that will tell you. Okay, that's another kind of way to hint at whether or not you're in the right direction. So for examples 3 and 4, I'm going to do letter A really quickly, and then I want you to do example B on both of them on your own. So example 3, okay, for each triangle, order the angle measures. Okay, it's very important you read these problems because they can be a little tricky. Okay, so make sure we're talking angle measures. And so, again, from least to greatest. Least to greatest. Again, you got to read the directions. It may switch it up on you and say greatest to least. Okay, but you have to be able to read and know which one you're looking for. So I'm looking for least to greatest, which is smallest to largest. Okay, so again, I want to go through and label my sides large, medium, and small. And so if we're starting with the smallest first, right, least to greatest, like our direction said, so smallest angle measure would be across from the smallest side. So that's side BC here. So what letter is missing from BC? That would be letter A. So angle A would be first. Then the next smallest would be my medium side, which is the side AC. And so across from that, what letter is missing from A and C? That would be angle B. And then lastly, we have side BA or AB, and the angle that's across from that, what's missing from A and B? Well, that's angle C. Okay, so there are the angles in order from least to greatest. I don't know what they are, but A is going to be the smallest, B is going to be the medium angle, and C is going to be the largest angle. Then for example 4, okay, order the side lengths. All right, so now I'm wanting sides, so I should not have any angles in my answer. And again, from least to greatest, smallest to largest. So letter A. Again, it will help if you start by labeling large, medium, and small. And so what side is across from our smallest angle, right? We wanted to go smallest to largest. So what side is across from angle C? What two letters are missing? That would be side BA. So we're going to start with BA. Then our medium angle is 65. So if we go across from B, what two letters are missing from B? And again, that's A and C. So the side AC. And then lastly, right, we really only have one side left at this point, but across from my largest angle, A, is the side CB, or you could say side BC. And there would be your answer. Okay, so go ahead and pause this for just a moment and try letter B on both of those and see what you get. So for example 3, letter B, again, this is back to angle measures. And so you should have angle B, angle C, and angle A as your final answers. Because again, we have smallest, across is to B, medium is across to C, and my large across to A. And then number 4B, again, now back to side lengths. Our smallest angle across from that is the side AC. Our medium angle is across the side BC. And our largest angle is across from AB. And that would be it. That would be all you would need to write for that. Okay. So there's a couple of questions down here at the end that I just want you to think about and maybe write an answer to. When two sides of a triangle are congruent, what can you then conclude? What can you come up with about the angles opposite those sides? So if the sides of a triangle are congruent, what do you know about the opposite angles? And so that's your first question here in the elaborate. And then the essential question check-in. Suppose you're given 3 values that represent the side lengths of a triangle. Can you use, or how can you use, one inequality to determine if the triangle exists? So how do you use one inequality to show that that triangle does in fact exist? So if you have any questions, again, please either come see me or ask at the beginning of class.